we're not actually going to show them to you until a bit later on in the course. So for the moment, we're just getting the ideas straight. And one of the things that's really important about a line is its gradient, or sometimes this is called its slope, gradient or slope of a line. So let's get that idea into our heads. So the gradient of a line, this whole thing's important. Let me just highlight the whole lot. Is the amount that the y value changes when the x value is increased by 1. So let's see if we can make some sense of that. That's our definition of what the slope of a line is. Slope or gradient. So if I have this line here, y is equal to 2x plus 3. That's a linear equation. We know its graph is a line. So what I'm going to do is I'm going to choose a value for x. So let me choose, for example, x equal to 0. I keep choosing 0 because I'm good at arithmetic with 0. That says y is equal to 2 times 0 plus 3, so y is equal to 3. No problems. If we were to go back to our picture, we've already seen that. We saw that when x was 0, y was 3. That's good. Now, I want to increase the x value by 1, so now I'm going to choose x as b equal to 1, and when I do that I get 2 times 1 plus 3, and now I get 5. And so my slope, my gradient, and so the gradient is the amount that the y value has changed. So it has changed from 3 to 5. So it has changed by 2. So the gradient of this line is 2. So in terms of pictures, over here, it says, and I've conveniently again chosen one off the graph, but it says if I increase my x value by 1, the y value, this would have gone nicely up here to 5. So this amount here is the amount that the y value has changed. So that's the slope or the gradient of the line. That distance there. And that's 2 units. That's how much my y value has changed. Interestingly, if I put, I'll try and get one on the graph now, let me do this. If I chose x is equal to minus 1, say, then in here I would get y is equal to 2 times minus 1, which is minus 2 plus 3, that's 1. So now I could say, look, as x has changed by 1 unit from minus 1 to 0, I could say, therefore, the gradient changes from 1, up to 3. So when x is minus 1, let's put it on the graph. When x is minus 1, y is 1. And when I increase x by 1 unit, that's how much the y value has changed. It's changed from 1 up to 3. And so again, that's my slope, sitting in there, 2. Is equal to 2. And therefore, the gradient of a line is constant. It doesn't matter where you work on the line, the gradient's always the same. So whether you've got large values of x, whether you've got small values of x, the slope is always 2. If I increase x by 1 unit, the y value will change by 2. Doesn't matter where you are. No. No. And in fact, we've got some examples here where it's not, okay? So good question. So it says, let's go back and have a look at these lines that we drew some pictures of earlier and determine their slope. So we're looking at these 4 lines sitting here, 1, 2, 3, 4. So we've got 2 choices at the minute. I mean, we're going to get smarter in a little while. But for the moment, I've got 2 ways in which I could do this. I could calculate x for a couple of values, calculate the other values for y, subtract them and see what I get. But I think it's probably easier if I just look at the graph. So sitting here. So I'm just going to say, by looking at the graphs, that's my method for the minute. And so I'm going to change the x value by 1 unit and see what happens. So let's start with y is equal to minus 2x. It's this one here. It doesn't matter what x value you choose. So for this one here, just so I don't clutter my diagram too much, I'm going to start at x equal to minus 2. The associated y value there is 4. Now, as I increase x by 1 unit, the y value goes down there. So the y value has gone to 2. So what's the increase in my y value? Minus 2, in fact, okay? So here, my slope, my grade, I keep using slope because it's quicker to write. My slope is minus 2. So a negative slope means that the y value goes down as the x value increases by 1. And as a result, your line goes that way. So that's the first one. So this one has a slope of minus 2. Let's look at B. And again, it's easier if we go to the picture. It says, choose yourself an x value, it doesn't matter which one. So in this case, I might choose x equal to 0. The y value is 2. Increase x by 1. I'll go to there. The y value is still 2. So how much has the y value changed? By nothing at all. So in this case, this has a slope of 0. So a 0 slope is a horizontal line, in fact. So this one has a slope of 0. The y value does not increase as I increase the x value by 1 unit. And so this one is a horizontal line. It's horizontal. This one, I would say, goes down as x increases. Let's have a look at x equal to 3. So I've got to choose an x value, so I choose x equal to 3. And this one's a bit awkward, because in here, if I increase x by 1 unit, I've jumped off the whole graph. To make this one make sense, I probably should do the next one first, and then I'll come back to this one. So let me do D before I do... do I take my pen over here? Yep. So let me do... I'm going to put that in there, slope. And this one here, I'll do slope. I'm going to do D next. So if I choose, go down here to D, in here. So choose a value for x. I might choose this value here. And so here I am at this point. It's a bit hard. It doesn't seem to go through any grid point. So I'll go there. Excuse me. Increase x by 1 unit. There it is. So that's 1 unit. The y value has changed from minus 9 on 4 to whatever that value is there. Whatever that value is. So that there is my slope. And so what I need to do is, I can't read off the graph what that slope is. So I'm going to have to work it out here. And I'll work it out the slow way, and I'll show you quicker ways in a minute. But for the moment, we had in here, when x is equal to 0, we said y was equal to minus 9 on 4. Now, when x is equal to 1, I have 2 minus 4y is equal to 9. So minus 4y is equal to 7. So y is equal to minus 7 on 4. So the value has changed from minus 9 on 4 to minus 7 on 4. That's that value there. And so the difference between those is a half. It's 2/4. It's gone up by 2/4, so it's gone up by a half. So my slope, in this case, is a half. Okay?
And the 2 x's there, x equals 0, x equals 1.
Yep.
Representing a positive changing by 1 x.
X has changed by 1 unit. I could have chosen x equal to 1 and x equal to 2, x equal to minus 1, x equal to 0, just as long as it goes up by 1. Yep, that's right. Now the thing is, this slope is positive, and so as we move across, the line goes up. All right? The negative one, as I moved across, the line went down. When it's positive, the line goes up. So we'll say that. So this one goes up as x increases. And what you can imagine, I think here, I've said here the line goes up. This line, as I went across 1 unit, it only went up a half. You can imagine if that number was 2, so it went up further, you can imagine that the line would get steeper and steeper. So the larger the number, the steeper that graph is going to get. Now, what if I chose something like 100, a slope of 100? This line, if I can do it here, would go way up like that. If I chose 1,000, up like that. And so as it gets larger and larger, our positive slope gets closer and closer to this thing here. And so for this extreme case where the thing is vertical, we say the slope is infinite. Because the slope's getting bigger and bigger and bigger and bigger. It's getting closer and closer to a line like this. So to make everything consistent, we say our vertical line has an infinite slope. Has an infinite slope. And when we do that, everything works quite nicely. So there are our slopes of the lines that we had there. So any equation of the form x is equal to something, x is equal to a constant, will have a vertical graph and an infinite slope. Any line that's horizontal will be y is equal to something, and it will have a horizontal graph and a 0 slope. And then you've got your negatives and your positives as well.
Basically just the other end of the scale from 0.
Yes, that's right. That's right. Now, the thing that we notice sitting here is that this slope, minus 2, those ones are a bit strange. Although, if we were to look at it, if I thought of that as 0x plus 2, then there's the 0. But again, you can't quite see it here, but if I were to rewrite this equation with y as the subject, I would find that the coefficient of the x is in fact a half, sitting here. And that makes some sense. Let me just scribble for a bit here. If I were to do this, in fact, I might even here, I'll do it with the y is equal to 2x plus 3, 1. If I choose some value for x, right, here's the y value. In fact, let me choose x equal to, now I'm not going to choose a specific number, I'll just call it a. Then y has the value 2a plus 3. Let me now increase my x value by 1 unit. So whatever the number a is, I now want to choose x to be a plus 1. 1 unit more. what's my new value for y? It's going to be 2 times a plus 1 plus 3, which according to my algebra skills, I can write as 2a plus 2 plus 3. And I know that addition is commutative. I can do it in any order. So I can write that as y is equal to 2a plus 3 plus 2. Now that's the value of y there. So how much has it increased by that? Where did that come from? It came from that times 1. So your coefficient is always going to give you your slope. Sitting there. Okay? So whenever you write the equation of the line with y as the subject, the slope is given by the coefficient of x. And to try and convince you even more that that's correct, let's rewrite 2x minus 4y equal to 9 with y as the subject. So e.g., if I go here, 2x minus 4y is equal to 9. Make y the subject. I've got minus 4y is equal to minus 2x plus 9. Divide by minus 4 and I'll get y is equal to minus 2. I'll write it minus 2 on minus 4, x minus 9 on 4. And so that is a half x plus, minus 9 on 4. And you can see, what did we have as our slope? We had our slope was a half, and lo and behold, there it is sitting there. So we know what the slope is. It's how much the y value changes. We know what it's good for. It tells us how steep the line is, or whether it's that way, or that way. And now we know how we can work it out, which is good. So I guess in here I could write a little sentence. I could say the slope of a line, is given by the, and I'll use math speak on you here, the coefficient of x, i.e. the number that multiplies the x. When the line is written as y is equal to mx plus something. So, i.e. the slope is m in there. We can say a little bit more about the slope, and I might in fact put that under there. So if I have a line like this, y is equal to mx plus k, if that's the equation and that's the line, we know that as x goes across once, y increases by m. All right, that's our interpretation of what's going on. Now, if I have the coordinates of that point there, let me call it A, and let me call that coordinate x1, y1, even though I've got it on the axis, it doesn't matter, I'll just say x1, y1, and this point here, B, and it has coordinates x2, y2. So not necessarily an increase by 1, but any other x value sitting there. Now, if you look at this picture here, you can see I've got a little triangle shaded there nicely. There's a little right angle triangle shaded there. And I can actually draw another triangle using the point B here. So here's another triangle. And these triangles share the same angles. Different size, same angle, so we call them similar triangles. And the thing is, with similar triangles, the ratio of corresponding sides are equal. So I can say by similar triangles, in here, the ratio of corresponding sides are equal. So the ratio, if I call that there, and this is a common thing to do, call it the rise, and I call this side here the run, then the ratio of the rise to the run in the first triangle is the same as the ratio of m to 1 in this triangle. So that says m is the rise over the run. So in other words, I can work out the slope. If I know 2 points on the line, they don't have to be separated by 1 unit, they can be separated by any amount, then I can work out the slope because I know the rise, it's how much the y value has changed. The rise is y2 minus y1, the y coordinates, and the run is, that's x2 minus x1. The run is x2 minus x1. So I can work out the slope. So the gradient is the rise over the run, and here is the rise over the run. So given 2 points that lie on the line, I can work out the gradient via that formula there, y2 minus y1 over x2 minus x1. And that is rather important as well. So when I work, I'll do it. It says here, imagine a line passes through the points minus 1, 2 and 3, 4. Determine the slope. All I have to do is say, look, that's my x1, that's my y1, that's my x2, that's my y2. And my slope will be y2 minus y1 over x2 minus x1. So I've got 2 over 4, which is equal to a half. So the line that passes through those points would have a slope of a half. So what that means is if I were to increase x by 1 unit, the y value would go up by a half. This thing has a positive slope. That's what it means. Okay, so the slope is one thing that experience has taught mathematicians is an important property of a line. Another important property is what's called the y-intercept. So the y-intercept of a line, and let me say, look, this whole thing's important as well. So the y-intercept of a line, it's the y value of the point at which the line cuts the y-axis. So let me go way back now, go way back here. Go back to this picture. So here is the line, y is equal to 2x plus 3. So the y, we know the slope of this line is 2. Now it says the y-intercept is the y value at which point, at the point that this thing crosses the y-axis. So here's my y-axis. Here's the point at which it crosses the y-axis. It's 0, 3. The y value of that is 3. Okay, so in this case, for the line y is equal to 2x plus 3, the y-intercept is 3. So part A, the y-intercept is 3. That's the y value of the point at which it crosses the y-axis. Now, we know sitting in here, I mean, I looked at the picture, but when the line crosses the y-axis, that's the point that has x coordinate 0. So to determine the y-intercept, all you have to do is substitute x equal to 0 into the equation. that will give you the y-intercept. So in here I have said, i.e. the y value when x is 0, sitting in there. So in part B, without looking at the picture, I can say when x is equal to 0, y is equal to 0. So that tells me that the y-intercept is 0. That's what it says. And if we were to now look at the pictures, which we have here, here's the line y is equal to 2x. It's coming down, 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 hits the y-axis, I should say, right at the origin, and so the y-intercept is 0. The y value of the point at which it crosses the axis is 0. And we can do that for the others as well. Oh, goodness me. As soon as we do that, we get to the tricky case. Y equal to 2. What happens when I put x equal to 0 there? Well, y is equal to 2, and you can see that quite happily. Here's where it crosses the axis, there, at y equal to 2. So that one has an x-intercept, y-intercept I should say. This thing has a y-intercept equal to 2. D, let's have a look at the line x equal to 3. Where does it cut the y-axis? Never does. It's parallel to the y-axis. So it has no y-intercept. Here, no y-intercept. It does not cut the y-axis. And E, well, we could look. We have it sitting there. It's minus 9 on 4. So from the graph, I could go from the graph, the y-intercept is equal to minus 9 on 4. Or I could do this. Or I could say, when x is equal to 0, I have minus 4y is equal to 9, therefore y is equal to minus 9 on 4. That would give me the y-intercept. Or I could do this. We saw before that if I had 2x minus 4y equal to 9, I could rewrite that with y as being the subject. And when I did that, I got y was equal to a half x minus 9 on 4. If I put x equal to 0 there, you can see that the constant term is your y-intercept sitting there. So, therefore, the y-intercept is minus 9 on 4. So, in fact, we can always see that the y-intercept is given by the constant term when the thing's written in the form y is equal to mx plus k. So we can say that. The y-intercept is the constant term when the line is written as y is equal to mx plus k. So i.e. the k. So when you write a line in this form, the coefficient of x is the slope, the constant term is the y-intercept. And you can just read those straight off the equation, which is nice.